bending moment, then we subjected to torsional loading, then we taught about how to represent this is a different topic. So these three type of loading we have seen, and then we discussed about welding symbols and permissible stresses. These things we have studied. In today's class, what we'll do is we will talk about the riveted joints. So unlike welding, which is a continuous joint, the riveting is a different type of kind of a joint where you have a welding is kind of continuous and it's a permanent. You can replace the joint or disassemble it and assemble it. So let's have few definitions before we go into design of riveted joint. Mechanical joints are classified into permanent joints like welding, and then there is separable joints. So even though the riveted joint, you have kind of a separable thing, it is still in some cases they classify riveted joints are still classified into because the way in which the rivets are driven, this process, once you remove it, you have to again redo the process. In that is the reason riveted joints are still classified into the permanent joint. Whereas in the separable joint, if you have bolted joint, you can remove the bolt and replace it at any other given point of time. So this is the kind of a classification of the thing. And riveted joints is one of the permanent joint. Further, most of the welded joints have almost replaced by the riveted. So now let us understand that the process of how many types of riveted joints are there and what is the rivet would be. So a rivet consists of a cylindrical shank with one end having a head and like as shown below. So if you look at it, this is the shank portion of the rivet and this is the head portion of the rivet. And the upper head, the other head like this head is formed on the shank by an upsetting process in a machine called automated header. So like this, you have a die under the kind of force, the shank would form a bulge, which would be like a kind of a head. So this is the process. So this process is also called as or this closing process is called point. So when you are mentioning the kind of rivet, the rivet is mentioned through its shank diameter. This is the shank. So shank diameter. So a rivet is specified by the shank dia. Example 12, 14, 16, 18, 20, 22, 24, 27, 30, 33, 36, 39, 42, and 48 are generally available. There are further two methods of riveting. One is hand riveting, and the second one is machine riveting. In the hand riveting, the protruding end of the shank is placed die and blows are hammered, whereas in the machine riveting, the die is a part of hammer which is operated by either pneumatic slash hydraulic or steam pressure. Further, either machine riveting or hand riveting is further classified into based on operating temperature. So one method is called hot riveting, is called cold riveting. So the differences are, in hot riveting, as we are discussing the process of making holes, there are three different processes: punching, drilling, and punching followed by reaming. Punching is the most economical one, but in the process of punching, the accuracy may be varying. Further, there can be secondary defects that might be coming out, whereas drilling is much more economical in nature and it gives better accuracies. So when you want quick work, people generally what they do is they do punching, and if there are any defects that are there, they follow it by the reaming process. So applications of the riveted joint. You can see it mostly in boilers, pressure vessels, and tanks. And the second category is like bridges, trusses. So these are the typical applications of the things. The hulls of ships are under special category because they are done for the curved panels. Further, in general, wherever fluid tightness is required, such as ship hull, and wherever the strength, rigidity, and durability are important. At such joints, riveted joints are preferred. Further, when alloys have poor weldability, such as aluminum alloys, riveted joints are preferred. Similarly, when high damping is required, their riveting is preferred as compared to welding process. Similarly, for heterogeneous joints where you have multiple materials. Riveting is preferred. So these are the kind of applications. Then advantages of over welding are, first thing is riveted joints are more reliable. So welding, unlike welding, riveting is not restricted to ferrous alloys. That is, one can also use non-ferrous alloys joints through riveted joint. During welding process, the heating and cooling cycles causes residual stresses. While riveted parts has no such thermal after effects. When we are saying this is for the cold riveting. For hot riveting, we do have certain stresses as we mentioned earlier, but compared to the welding processes, these are much lower. Thermal effects are much lower in nature. The quality of the riveted joint can be easily checked. On dismantling riveted joint, the components are less damaged when compared to welding. So these are some of the advantages of it. And some disadvantages are material cost is more than welding process. Second, labor cost is also high. Next, riveted joints have more weight than welded assemblies. Further, riveting process creates more noise than welding, and due to holes driven in parent material, they are subjected to stress concentration. So these are the things. So advantages, disadvantages. Then we will see what are the types of rivet heads. These are certain types of rivet heads. The first one type in the first figure shown is a snap head rivet, or it also represent something like a button which we generally wear. So it is also called as button head rivet. And it is used in generally in boilers, pressure vessels, etc. The next type is called pan head rivet, and it is sometimes called as cone head rivet. And this is mainly used in boilers and ship hulls. And the third one is called counter sunk head rivet. It is generally used where protruding head is objectionable. These are generally used in ship hulls below the water line, because in the below the water line, if there are protruding heads, that causes higher drag coefficients, and that will hit on the economy of the ship while kind of maintaining it. So that is the reason when you don't need a protruding head, a counterset head is kind of used. So this is a flat head kind of a head. This is when you see it, it is the top portion is really flat, and the height of the protruding head is very minimal compared to other kind of a pan head or a countersunk head. So this is also kind of preferred sometimes when you want kind of less protrusion, but still you want to have a proper head. So this is one kind of things. And so sometimes these flat heads also called as tin man's head or rivet head, and they are used in light sheet metal work like buckets, steel boxes, and air conditioning. Ducts. So the next one is called half countersunk head, and it more or less represents like a countersunk, but with the reduced the height of the protrusion, and hence it is called half countersunk head rivet. So, and depending upon the applications, there may be a change of rivets, and the standards are also different for the different types of things. And all the rivets for the different types of head should have following desirable properties. So the desirable properties of rivets are the rivet should be sound, free from crack, flaws, burrs, seams, pits, and any other defects. Secondly, the head of rivet should be concentric with the axis of the shank. Next is the end of a rivet should be square with respect to axis. So these are the some of the things, and the relationship between the length and the thickness of the plate is certain criteria is there. So length of the shank is given as L is equals to T1 plus T2 plus A, where this is length of the shank, these are thickness of the connecting plates, and A is the length of shank portion necessary to form the closing head. That is, I will show you a picture. So as you have seen, the total length of the shank is T1 plus T2 plus the A, which is the minimum portion that is required to form the closing head. And generally, the value of A is equals to 0.7 times D to 1.3 times D, where D is the diameter of the shank. This is the length of the thing. Then we will talk about different types of riveted joints. There are the types of riveted joints fall very similar to that of the welding joints. The first type is a lap joint, and the second type is a butt joint. Further, in the lap joint, the lap joint is further classified into several things. Those can be classified into single riveted, lap joint or double riveted lap joint or triple riveted lap. Further, these two are classified into chain pattern or zigzag pattern. Let us show you through the pictures the types of riveted joints are there. So this first one is the single riveted lap joint. There is only one rivet line across the front view. So, and you have three within this line of the things. And here, if you look at the cross section, there are first one and the second one. This is double, and the pattern is in the form of a chain. So it is double riveted lap joint, because this is a lap, this is double riveted. This is also double riveted, but this is chain type. See, the order is there as a chain, as a link 1 to 1 here, whereas here they are not both in the same order. There is some order zigzag is there, so and hence this is called zigzag, but still double falls under double riveted zigzag lap joint. So there are certain terminologies one has to understand when you're doing with the riveting joints. Those things are mentioned here. See this T, this angle, and this M, PT, PD, and other kind of things. So let us define certain terminologies and then we'll go forward. So in the terminology, first one is pitch P. The pitch of the rivet is defined as the distance between the center of one rivet to the center of the adjacent rivet in the same row. Generally, a pitch value of 3D is kind of used where D is shank dia. Next one is a margin, M. This is the like paper margin. The margin is the distance between the edge of the plate to the center line of rivets in the nearest row. Usually this is half of that. Then is the transverse pitch. It is defined as back pitch or row pitch, and it is the distance between two consecutive rows of rivet in the same plate. Next is the diagonal pitch. It is the distance between the center of one rivet to the center of the adjacent rivet located in the adjacent row. So these are the certain things, and one has to note that because of the lap joint always experiences a bending moment. Whose value MB is equals to generally P cross T, and where P is the eccentric force and T is the thickness of the plates. So let us actually show it. So if you see a kind of a lap joint, this is a P force, and this which is acting in the center of this plate and acting at the center of that plate. So between the lap, this thickness is T by 2 and that thickness is T by 2. So the total thickness is the T from this central line of P to the top central line P, which are again acting in the opposite directions to each other. That would generate a moment of MB is equals to P cross T, and because of that movement, on resisting the movement, it would deform in this kind of manner when the magnitude of MB is very high in nature. Okay, these are the kind of certain kind of things that are there about the single lap joint. Okay, then there are scenarios of a lap joint with kind of uh, multiple multiple rivets that will also have similar kind of things of the bending moment that has to be the bending moment effects would be minimal. The next type of rivet is the butt joint. Under the butt joint, there are several different types of classification. So we will first start with the butt joint with a single strap. So in this, two plates which are joined adjacent to each other are joined through kind of a connecting plate which is only placed on the one side of it. So now you can see here in this case, this is that this plate is not a plate. This is the first plate and this is the second plate. The top plate which you are seeing is the strap, and this plate is connected to strap and this plate is connected to strap using a line of single rivets, and this assembly is called a single strap butt joint. And similarly, this is called a single strap butt joint. Similarly, you can have a double strap in which the backing plate is provided on the both sides. So in this is the plate A, which is in the in between. This is the plate B or plate 2, and they are connected by a backing plate or a strap on this side, on the top side, and on the bottom side, this one. So this is called a double strap butt joint. And there are other cases where you can have it double riveted, because in each plate you have only single things. You can also have multiple rivets on the double things. So that case, so again, this is the backing plate. Sorry, this is the central plate, plate A, plate B. The top one is the strap plate, and the bottom is the bottom strap plate. But on the each side of the joint, you have two rivets. This side it is two, that side it is two. So it is double riveted, double strap. So this is kind of things. And in the double strap, you can have a different kind of a framework. Generally, what they use is a diamond kind of a pattern, which is more popular in terms of bridges, where they provide this kind of a butt joint with a diamond in shape. So this kind of a joint is called a diamond joint, because you can see the strap plates are cut in the form of a diamond. Joint, or also called as lozenge joint. And this is also the most economical joint, because you're reducing the number of rivets at this place, because as it goes farther into the thing, the effective transfer load becomes lesser and lesser, and hence you require lesser number as you go inside into the things. And if you use a full pattern, that would cost you more material and more labor, whereas in this diamond pattern it is less, and hence it is called most economical kind of a joint. So this is the things. And then we'll see what are the type of materials that are used to make the rivet. So the next section is on rivet materials. Generally, rivets are made up of mild steel, and there are two varieties. First one is hot rolled steel rivet, or a rivet bar, and the second thing is high tensile steel rivet bar. The chemical composition of these materials are generally So depending upon the type of the grade, you can see that if it is a hot rolled steel for any given diameter up to 40, it would range, the SUT would range between SUT, but depending upon the cross section, the SYT would be dropping from 260 to 240, and percentage elongation for a hot rolled steel rivet is around 23%. Similarly, for high tensile steel rivet, the SUT is 460, whereas SYT would vary from 310 to 280, and SSU is 370, and the percentage elongation goes down to 22%. Whereas steel rivet bars for boiler application is generally of the grade of 37BR, and its thing varies between 360 to 440 Newton per mm square of SUT, and SYT is around 220 to kind of 200 with the greater diameter. The SYT is on a lower side with a percentage elongation of 26. So, and the steel rivet bars for the boiler applications are of the grade ST42BR, and it has very high strength of SUT ranging from 410 to 500, whereas SYT is lower of the order of 250 to 240, and percentage elongation is also kind of lower. And these things are generally specified by the codes like these things are the codal specifications from IS 1148 1982, 1149 1982, and IS 1990 1973 are such kind of things, which gives both the composition and the materials using these standard codes. Now, there are several types of failures for the riveted joint. So what we'll do is we will just list out the types of material failures for the rivet, and in the next class what we'll do is we will try to see how the design of the rivet has to be done to avoid such failures. So the types of failure of rivet are shear failure. Second thing, this is the shear failure of the shank, and the second one is tensile failure. Of the plate between two consecutive rivets. And third type is crushing failure. Fourth one is shear failure of the plate in the margins area and tearing of the plate in the margin area. Out of these 5 criterias, mostly the first top 3 are kind of critical. So what we'll do in the next class is we will try to define the strength of the different failure process, and then we will introduce an efficiency for the joint parameter, and based on that we will solve a couple of example for a different pattern of joint structure, and later, if time permits, we will also try to solve for the the eccentric loadings of the eccentric loaded riveted joint and longitudinal butt joint for a boiler shell which is under curvilinear form. So with these things in the next class, which would be on the next Wednesday, we will kind of take off for this day and we'll meet on the next day, next Wednesday.